So today we're going to look at just a quick overview of factoring. So that's our second part of our polynomials unit. So the first thing we're going to look at is finding our GCF, or greatest common factor. So sometimes to factor, we just need to pull out a GCF. So we are going to look for the biggest number that goes into all three terms and the biggest exponent that we can take out. So the exponent that you're going to take out, you can only take out the lowest exponent. So this one's to the first. So we can only take out x to the first because it's in all three terms. So I'm going to write that out in front. Then we have 3, 9, and 18. 3 goes into all of them, so we can take out a 3x. So what we're going to do is divide everything that's left by 3x, and that's what's left in our parentheses. So 3x to the fifth divided by 3x. 3 divided by 3 is 1. And then 5 minus 1 gives us x to the fourth. Negative 9 divided by 3 is negative 3. And 3 minus 1 gives us x squared. 18 divided by 3 gives us 6. And then the x's cancel out. So this would be this polynomial factored by taking out the GCF. Because if you multiplied the 3x back in, you will get that original problem. The next thing we have is difference of two squares. So whenever you have a perfect square as your first term, which x squared is a perfect square, and a perfect square as your second one. So remember our perfect squares are like 1, 4, 9, 16, 25, 36, 49, and so on. When you have two perfect squares and they are being subtracted, we can factor them. If they are being added, we cannot factor them. That's why it's called difference of two squares. So what you're going to do is take the square root of your first term. So the square root of x squared is just x, and write it in both first spots. Take the square root of the second one and write it in both of the second spots. So the square root of 16 is 4, and then 1 is plus and 1 is minus. So if we multiply this back out, we're going to get x squared minus 16. Now it's the same thing for this one, but you can have a leading coefficient. So 4 is a perfect square, x squared is a perfect square, 9 is a perfect square, and they're being subtracted. So for the first two spots, we're going to take the square root of 4x squared. So we get 2x. And take the square root of 9, we get 3. And 1 is plus and 1 is minus. So whenever we have two terms, you always want to check for a GCF, or difference of two squares. Now we're going to factor a trinomial without a leading coefficient. So, well, our leading coefficient is 1. So we have some different sign rules. So I put all the different sign combinations up here. But what we're going to do is really work backwards. So we're always going to set this up. If our first term is just x squared, we always have just x and x in both of our parentheses. And then we work backwards. So we want two numbers that multiply to the last number. So two numbers that multiply to 12. And then add, or whatever the sign is, to the middle number. So I always like to start out by just listing my factors of 12. So we have 1 and 12, 2 and 6, 3 and 4. And then we want two that add to 7. So it'll be 3 and 4. Now to figure out what signs go in each of these sets of parentheses, if your last sign is positive, it means they're both going to be the same sign. And we look back and they're both whatever that first sign is. So in this case, we get x plus 3 times x plus 4. If we multiply that out, we'll get x squared plus 7x plus 12. Now same thing for the next one, working backwards. We want two numbers that multiply to 15 and add to 8. So we're going to start with our x's in there. So I'm going to list out my factors of 15. We only have 1 and 15 and 3 and 5. 3 and 5 add to 8. And it doesn't matter which order you put them in. Then our sign rules, when your last sign is a plus, they're the same signs. So you look back and they're both whatever that first sign is. So we get x minus 3 times x minus 5. Now these next two are a little different because we have a negative sign last. So we're going to start out with our x's in our parentheses. So we want two numbers that multiply to 20 and subtract now to 8. So that's why you work backwards. So I'm going to list out my factors of 20. So we want two that subtract to 8. 10 minus 2 would give us 8. So our factors here will be 10 and 2. And then this one is more difficult because when your last sign is negative, it means they're opposite signs in the parentheses. So one is plus, one is minus. And you look back at your first sign, your bigger number gets that first sign. So we have x plus 10 times x minus 2. And then for this last one, start out with your x's. And we want two numbers that multiply to 28 and subtract to 3. So we have 1 and 28, 2 and 14, 4 times 7. 7 minus 4 will give us 3. So we're going to use 7 and 4. And when your last sign is a negative, they're opposite signs. So we look back and our bigger number gets that first sign. So again, when you're doing these, always work backwards to see if you're adding or subtracting to that middle number. And the sign rules. These are the 4 possible sign rules. So just when your last sign is a positive, they're both the same signs. And you look back and they both get whatever that first sign is. And when that last sign is negative, they're opposite signs. So you look back and the bigger number gets that first sign. Now sometimes you have to check for a GCF and then factor. So looking at these 3 terms, you should always check to see if a number goes into all 3 of these numbers before you even start. So in this case, 2 goes into all of them. So I'm going to pull a 2 out first, and we can divide each number by 2. So we have x squared minus 9x plus 20. And now it makes it easier to factor because we have a leading coefficient of 1. So now when we factor, we have our x and our x. We want two numbers that multiply to 20 and add to 9. So we have 1 and 20, 2 and 10, 4 and 5. 4 plus 5 gives us 9. And then when your last sign is a plus, they are the same signs. So we look back and they're both that first sign. So if you pull out a GCF, make sure you still keep it in front at the end, but you should always check for that first. The last type of factoring that we're going to see is when you have a leading coefficient that is greater than 1. So I would still check first to see if a number goes into 3, 5, and 2. Nothing goes into all 3 terms. So we're going to need to look at a different method to factor this. So there's 2 different ways you can look at it. I'm going to go over both of them. So the first one is just by thinking about it. So before we always had x and x as our first 2 terms because we wanted it to multiply to x squared. But now we want them to multiply to 3x squared. So one of them needs to be a 3x and the other one needs to be an x. So when you were foiling this back out, you would get 3x squared. So now your last 2 numbers need to multiply to 2. But what's different here is that the products of right there and right here and here need to subtract to 5. So you would just start playing around with it. Like if I put a 2 here and a 1 here, this 2 times x would give me 2x. This 1 times 3x would give me 3x. But that adds to 5x, it doesn't subtract to 5x. So I'm going to switch them around. 1 times x is 1x. 3x times 2 is 6x. Now 6x minus x does give us that 5x. And then it's opposite signs. And your bigger product now gets that first sign. So this 6x gets a plus, which means it goes with the 2. You can always check your work by multiplying it back out. So do our 3x times x is that 3x squared. 3x times 2 is 6x. Negative 1 times x is negative x. And negative 1 times 2 is negative 2. combine your like terms, and it is our original problem. Now the other way you can think about this, your first step is going to be to multiply your leading coefficient by your last number. So 3 times 2 gives us 6. So we're going to kind of replace this 2 with a 6. So now we want two numbers that multiply to 6 and subtract to 5. So two numbers that multiply to 6 and subtract to 5, you can have 1 and 6, or 2 and 3, and it would be 1 and 6. So we're going to put those as our last two terms. And then your first two terms are going to be whatever your leading coefficient is plus x. So pretty much this first term without the squared. So we're going to write 3x and 3x. And then we have, that means it's opposite signs. So we look back, our bigger number gets that first sign. So we have 3x plus 6 and 3x minus 1. But then your last step here, and you cannot forget this step because if you guys just multiplied this back out, it would not equal this, is to divide out any GCFs that you can. So this first one, 3x minus 1, nothing goes into 3 and 1, so I'm just going to copy it down. The second one, 3x plus 6, 3 goes into both of them, so we're going to divide them both by 3, and that 3 just goes away. We don't write it in front. So we're left with x plus 2. So we'll practice both methods in class, but you guys can use whichever method you prefer and come to class with any questions you have.